All right. Hello, everyone. This is the
Hello.
Secure Development with Docker workshop. If you were planning on attending a different workshop, it's not too late to leave. But if you are here for this workshop, welcome. We're very glad to have you. Before we get started, I do want to talk a bit about what this workshop is not. It is not a Docker file best practices workshop. There are plenty of resources online regarding how to orchestrate your Docker files. There's blogs and all these sorts of things. If you don't have time for all that, basically clean up after yourself in each layer. Don't install things you don't need. Don't run as root. There, Docker file best practices. If that's what you're here for, you're free to leave. But what this workshop is about, what we're focusing on here is a more holistic approach, sort of moving beyond the Docker file, moving beyond your code, even moving beyond your dependencies to a large extent to take a holistic view of security in your development as you're going forward. So this workshop is really about extending your view of security beyond the bits and pieces that are in your control into your whole software development lifecycle, into what we're calling the software supply chain. And this workshop is organized into 4 segments after we get through the welcome and not counting the wrap up. You know, basically each of these segments has a 15-minute sort of introduction, talk through, presentation portion, and then a half-hour hands-on. And those times are approximate. Some will run a little shorter, some will run a little longer, but we'll get you out of here by noon, I promise. There's a couple breaks sprinkled in as well, so we'll all get through this happily. And we are going to start out where most people start when they think about security, and that's with CVEs. And we'll have a session going through those and how to remediate those with Docker Scout, how we do it at Docker. Then we're going to take a step back and look and introduce the concepts around the software supply chain and talk about how you can use Docker Scout to connect the data model of how you develop things. And then we'll go into what that looks like within the Docker file, within Docker images, with information around provenance and software bills of material to enhance the content and the information that's provided in your Docker images. And then we'll wrap up with policy. And that's a scary word for a lot of folks because it tends to be something that comes down from on high. But this is Docker. We are Docker. We do things with a developer mindset. And so this is a developer approach to policy and an automated approach to a policy and how Docker Scout can help you with that. Just in the way of introductions, my name is David. This is Eve. We're going to be running this workshop. We have a few people around here to help out if you need any help while we're doing the hands-on stuff. I'm going to be doing the presentation portions largely, and Eve is going to be running the hands-on sessions. Okay? So before we begin, how many of you all got an email with instructions on how to set up your laptop or your workstation? And good, almost everyone. How many of you followed the instructions in that email? Slightly fewer hands, but still a lot of hands, so that's good. So we're just going to give everybody a few minutes to kind of set up the workshop, set up your laptop. So basically what we want is you need to have Docker Desktop 4.24.0 installed, and you need to be logged into Docker Hub in Docker Desktop. And so you can go to the check for updates to see if there's a newer version. If you don't have Docker Desktop installed at all, you can go, search for Docker Desktop install, and you can download it. That version will be 4.24, so you'll be getting the latest version in there. If you have it installed already, you can go to About Docker Desktop to see what version you have. or you can just go straight, if you haven't updated it, let's say within the last week or so, go to the check for updates, and that'll help you download it and get it installed. Essentially what we want when you're done is if you go to About Docker Desktop, you're going to see version 424 here in the window that pops up. And when you're on the Docker Desktop dashboard, in the upper right-hand corner, you're going to see your Docker Hub username, or at least the first 6 letters of your Docker Hub username in this upper corner to show that you are logged into Docker Hub. So we'll give folks couple minutes to work through that. Oh, the Wi-Fi. Yeah, so it's DockerCon, right? And then Go Moby 23 exclamation point. And then the G and the M are capital. What's the SSID of the network again? DC23 attendee is the SSID, and the password is Go Moby 23 exclamation point. That's capital G, capital M.
I couldn't quite hear that middle part when you're saying go what?
Moby, M-O-B-Y, so like Moby Dick, the whale, by Herman Melville. Or the electronic music artist, if you prefer. Oops, that's a hair trigger. What's this thing doing? Is there a way to... Okay, that's better. Still got some people coming in too. For those of you who are just joining us, the Wi-Fi is DC23 attendee. The password is Go Moby, capital G-O, capital M-O-B-Y 23 exclamation mark. Yes? I'm sorry, what? 423 you're seeing?
So I clicked.
Ooh, sorry.
I clicked it. It just gave me 423. That's the latest one that it's given me. So this is the version that I'm on, and that's the version that it's given me. Would that work or?
No.
That's the first two.
It's weird.
Okay. Okay, so
Well, maybe you have to do 23
Yeah, so if you-
24. I don't know.
Yeah, that's what I was thinking, but I thought I asked.
Yeah, I don't know. I'm not sure. All right.
okay, so if you don't see the right version, if you click on the check for updates, you shouldn't find it. Sometimes, the version is just, there's some canary stuff, so you don't always see the latest version.
Will it download the latest, though?
Yeah, sometimes you just have to go to the check for updates to find the final version. That even if it's not already in, like on the website or stuff like that, so we can, if someone is stuck on the 23.
Yeah, he has 21, and it's downloading. It says 23 is the latest on his, so.
Okay.
So maybe you have to go 23 and then 24, not sure. Or maybe it's downloading 24 and it just doesn't know it. While you are downloading stuff, you can also move on, do this concurrently while you're waiting. If you're downloading a new version of Docker Desktop, while that's downloading, it can be somewhat of a large download. You can also do this in parallel. We basically want you to clone the workshop repository from GitHub. It's under the Docker organization. It's DC-23-secure workshop is the Git repository. You can clone it with the Git CLI, with Git clone. You can use the GitHub CLI if you want, GitHub GH repo clone, the slug. Or if you're, we are going to be, editing files and stuff like that. So if you want to do it in your IDE, you can do that as well. But I'm assuming you know how to do that better than I do. So no instructions for that. The Pinafore or whatever? That's fine. I'll just do this.
Yeah, the online chat thing.
Yeah. Well, I'm just not going to mention it. How are folks doing with the Docker Desktop and the GitHub repository? 1 thumb up, 2 thumbs up, 2 thumbs down? I see people with 1 thumb up, so I'm guessing that means you have Docker Desktop. Okay, we're going to go left thumb is Docker Desktop, and right thumb is GitHub repository. All right, I'm seeing some double thumbs. Okay, looking good. Oh, we got one sideways. That's in progress, I'm going to guess. All right. Oh, he's a little further in progress. He's about 3/4 of the way done. This is good. This is good. We're making progress. Progress is good. It's important. If things go horribly wrong, even I'll just hide behind these pillars. And we'll just ride it out from there. All right, for those of you with the 2 thumbs up, this is the kind of the final piece of the puzzle for the setup. These instructions are actually in the README of the repository that you just cloned, or that you are cloning, or that you hope to clone very soon. But I also put them here. We're basically going to set an environment variable, all caps ORG. And that's going to be, we're going to set that equal to your Docker Hub namespace, which is usually just your Docker Hub username. If you have a, kind of a pay account there, you can create organizations and stuff like that. So you could create an organization and do it there. But most of you with free Docker Hub accounts are just going to put your Docker Hub username on the right-hand side of that equal sign there. Then we're going to set up Scout configuration. We're going to set the organization to that variable that you just set, your Docker Hub username. And then we're going to enroll Docker Scout onto your organization. That basically enables Scout on your organization, so it allows it to sort of keep track of what's going on and help you out with what we're going to be doing today. And that's the Scout setup. Those 2 commands. The rest is setting up Docker Compose. And so we're also going to be leveraging Docker Compose today. And so we're going to set up the environment. So we copy the env.dist file to .env, and then edit the namespace setting in there to use $org. So the value of the org environment variable. You can put your namespace in there too, or $org. Either one would work. Or if you don't want to do 2 steps, you can do it in one using sed with that commented out command right there. Then once that is done, you're going to do git checkout hands-on 1. So that's a tag that's pointing to the code for the first hands-on section. And then you're going to run docker compose build with the profile of images. And what that's going to do is start to build the images that we're going to be using in the first hands-on. And that's going to likely require you to download some base images and do some things. And so we're going to get that started as we go through the first talking segment of the workshop, so that can build and everybody can happily share the network. All right. So give everybody a minute to kind of go through that. And again, those instructions are in the README of that repository near the top. But we're not waiting for the compose build to finish. We're just getting it started and sort of setting it aside as we move on. So give folks a minute to do that. All right, while that's running, we'll go ahead and get started into the first segment where we are going to talk about vulnerabilities. And this is really where a lot of people start the journey towards security, right? How do you secure your software? Well, for most people, that means, I scan my dependencies using some tool, right? Sneak, Scout, Gripe, Trivy. Maybe I scan my container images with similar tool, right? Maybe I even scan my code using some static checker, right? And why do we do that? Why do software developers scan your code, scan your software, scan your images, scan your dependency? Well, usually it's because someone told you to, right? You had some security review, you were going for SOC 2 certification, and somebody needed to put some policy together about how you're securing your software. So they said, well, you got to scan your software. And so either you're on the left-hand side of this slide where you're a developer and someone told you to do it, or you're on the right-hand side, you're the security engineer or the auditor or whomever and says, I don't scan software, I tell other people to do it. And then we pretend that once you scan the software, everything's good. And what does this scanning of software look like? It usually means that in your CI/CD script, you add some dependency scanning checker to it. You could add some code scanning checker to it. You do your build, you do your Docker build, you add a container checker to it. And if your CI/CD system isn't set up real well, then you got to go into every repository. And in the wonderful age of microservices, that's a lot of repositories oftentimes. And you need to update your CI/CD script across all these things, and it's kind of a pain. So what if I told you you could stop scanning your software while improving your security? Right? And normally in a technological talk, there would be a meme here of Morpheus from the Matrix with the top text, what if I told you, and the bottom text with the rest. But there's 2 reasons that's not in this talk. one is copyright, and 2 is that Morpheus never actually said that. In fact, he said pretty much the opposite. He said, I can't show you I can't tell you what the Matrix is. You can only see it, experience it for yourself, or something like that. But anyway, what if I told you you could stop scanning your software while improving your security? Right? So, but before we get to how we would do that, let's lay some foundation for what we're talking about. I've used the term CVE, which stands for Common Vulnerabilities and Exposures. Right? And essentially, these are cataloged, identified, shared, publicly disclosed cybersecurity vulnerabilities. So those could be in things like operating systems, right? There's a problem with the Linux kernel, right? It could be in your dependencies that you're downloading from somewhere, OpenSSL or hypothetically Log4j, hypothetically. And it can be in your own software. You could, typically those aren't going to be CVEs, but you can introduce bugs in your own software because those typically aren't going to be public things. These are typically curated and made usable by a number of different sources. So once these CVEs are identified, there are organizations like Linux distribution providers, like language toolchain providers, like packaging systems, like GitHub, source code repositories, that take this information and package it into a usable format, a database, a feed, JSON something, that then can be used by these scanners to identify, are you using this software, are you using a vulnerable version of this software? Okay, I'm going to flag this as a problem. So that's CVEs. Next thing that we want to make sure that everybody has a baseline understanding of is container images. So hopefully if you're in this room, if you're online in this, you probably know a thing or two about containers images, right? But just in case, we want to just remind everybody that container images, these images are created from, are comprised of layers. And each of these layers maps to an instruction in a Docker file. Okay? And any instruction, any layer that introduces data into the image can introduce vulnerabilities. So this first line from Golang starts your image at the Golang image. And so that introduces the entire Golang image into your image, right? When you copy your source code in, you're copying in your source code can have vulnerabilities. When you download your dependencies, you're downloading a bunch of source code, that can have vulnerabilities, okay? Then you do your builds, which generates your binaries, and then you sort of set your entry point. But at any point where you're adding data into your image, you can be introducing vulnerabilities. So it's important to understand how those vulnerabilities get in and where they get introduced, by what steps. We're also going to be using Docker Compose. If you did the setup already, we already ran one Docker Compose command, but just as a refresher, it's basically a tool that allows you to orchestrate a set of containers, volumes, networks, these sorts of things that allow you to run more complex applications than just a single container. And so we're just going to be using that largely for ease of use, but if you're interested in this, if you don't know about it, there's lots of information online where you can learn more about it. And then I've mentioned Docker Scout a few times. Docker Scout is the tool that we're going to be using and talking about today. And while right now we are talking about CVEs, while we're talking about vulnerabilities in this segment, Docker Scout is not a CVE scanner. Docker Scout is a complete software supply chain management system. There are 3 interfaces for it that you can access within Docker Desktop. There's a CLI, and also at scout.docker.com. Okay? So what do I mean when I say it is a complete software supply chain solution? Well, that's actually the topic of the next segment. So for now, before we get into that, what we're going to do is our first hands-on exercise, because this, after all, is a workshop. We wanted you to get your hands dirty, because everybody knows that keyboards are full of bacteria. So we're going to let you get your hands dirty with some hands-on work. And Eve is going to do that. If you've done any meddling, you can reset to the appropriate code in your Git repository with git reset --hard hands-on 1. But we already checked out that tag in the setup, so if you only ran the compose command, you should be good to go here. Eve.
Okay. So I will. So first, do anyone already build the image, or are there still people not working?
Is anyone not ready to go and need some help? Just raise your hand.
Okay. So what I will do, is I'll just do, some of the step here, and the goal is for you to do the same and all the others from the README. So the first thing was just to have this compose.
That's the only issue.
You should be able to do
So I will build the image. Why? Oh, okay.
Yeah, you can start the compose and stuff.
I forgot this part. Yes. Okay, so you should have done this. And the first thing we can do is
Let's get on what?
go, it's on the wrong
Are you
display. So to go to desktop, so I know desktop is a bit small, but I can't really make it bigger. So you should have 2 images, or maybe more if you already have others. And what you can see, you can start to explore these images. And we added a new view sometimes. Go, okay. Why? Oh, it's probably the wrong one. No. Should be better soon.
I'll be right back.
Yeah, okay. So that's the beginning of the story. You just build an image, and you can see there's some vulnerabilities at different places, depending on it can be on the latest image, it can be on the base image, so like it's the equivalent of the from. And so the idea first is just to start looking at the image. You can explore like the different vulnerabilities, the different packages, etc. So the first thing is just for you, to explore this image, and then I will just display the instruction also on the screen and start to see what we can do with that. So the instructions, ends on 1. And I'm just opening the file. Yes. So that's the idea. The idea is you go to this image, and the first thing is just to start to explore everything you have in Docker Desktop first. So like the hierarchy of the image. So everything that is needed to build the image, you can see that in desktop. And you can start to explore the different vulnerabilities, the different packages. There's a lot of different ways to find the information you want. And once you're all there, we can see the next step that we'll see, or we can remediate some issues. So we have, if we look at at desktop, we know, we basically know 2 things. We have some vulnerabilities coming from the base image, and we also have some vulnerabilities coming from the image we built. So the other instruction we added to the Docker file. So we can fix them in 2 different ways. But yeah, so first, I don't know if it's working for you. Do you have, the image working, desktop working? Yeah, or better, who doesn't have that? So we can know if you need help or no? Everybody's okay?
Yeah, you should be able to do this with the current version. So it's only like the policy stuff
Okay.
that you're going to need.
So I can, the thing is it's a bit smaller, but so we can see on the image, the first, so it's based on Alpine. We have some vulnerabilities. And one thing we implemented in desktop is we have these little recommended fixes here. So we can, just with that, know that, okay, we found that you have vulnerabilities inside your base image from your from instruction. And we can offer some ways to fix that. So if we look at the change base image, we just need to pick the right one. We'll explain a bit later why we don't have the right one for now. And it will just show you some recommendations. So we know that, okay, maybe we should use the -318 and not the 314 we are using in the Docker file. And we have instruction to change that. So if I just display so it's the Docker file. So that's the Dockerfile of the first image we build. So we have this from Alpine 3.14 and a digest because we pin one version with vulnerabilities. So the thing with Docker Desktop is you can find this line, and you can also find the right recommendation to update this one. Depending on what you want to do, you have different kind of recommendation, like you just want minor update or a bigger one, etc. So, yeah. So the idea now is if you pick this line here, I mean the recommendation, and if you update the Docker file, you can rebuild it and see the changes in desktop. I will just do that at the same time. It's there. So if I just, it's in front-end file. So if I just remove that and add from Alpine 3.18 and just rebuild. Yeah, I will just do something else. I will just edit the tag in the compose file. It's just so I will not override the previous image, just have a new one so we can see the differences. And just rebuild. So it should be good. Yeah, so it's downloading the new base image. And just reinstall the rest. Yeah. Okay. Nope. Okay. And it should be good soon. All right. And so if I go back to desktop, it's this one. I can go back to my image list. So I have a new one. So the V2 is the one I just built like 8 seconds ago. It will just analyze the image. And then boom, my from image, this time it's green. I mean, I just fix all the vulnerabilities from my base image. So I still have vulnerabilities because I added something bad in the rest of the image. But the basic stuff, I mean, my base image, from desktop, you can just see, okay, you should pick this one, and it will just fix whatever you want. So depending on the case, we have all the explanation of why we should pick one, like is that smaller, or do you have less packages, or is that pushed more recently, etc. There's different reasons we recommend one or the other, but you can find all the details there. So, did you manage to have it that working? That good? No? It's slow? Okay. Okay. Okay, we can just wait just a bit for, because you will need the different images for the other stuff, so. So, I mean, during the network download, I can just show you the next step, and then you can just play with that. So the other thing is, I mean, we did that with desktop, and we can also do that directly on the CLI. So if we run, I mean, there's new DockerScout command line, and we have like one command that is the CV command, and we just pass them in the same. It's like to pick the right one in desktop, and oh yeah, a new one. Why? Okay, what? I did wrong. I think I didn't pick the right image. Let me just check what I did. So what's the problem?
Can you increase your font size on that? Can you increase the font size on that?
Oh, yeah, I'll do
The
that.
Command Shift plus.
Yeah. So. One. Okay. Yeah.
Is there
So
a way to sharpen the screen?
So it's basically on the CLI the same things as in desktop. So
Sharpen.
we have this small overview of the image. So it just displays like the target, the digest, exactly.
Screen.
The platform, and just a very brief overview of the different vulnerabilities of the image, whatever it's coming from the base image or directly from the other layers. And then we have all the details. For each package, we can see what are the different vulnerabilities. So there's, I mean, we can have a lot of vulnerabilities there, but yeah. And other than that, if I just find again my, yeah. And one thing you can do with that also is to explore the help of the CVS command, because there's a lot of different filters. Like I want to see only the vulnerabilities for the base image. I want to see only the vulnerabilities, I don't know, for the Node.js packages, etc. So you can filter all that on the CLI. Or you can also, let me just again. You can also like display just the vulnerable packages, so it can be helpful just to understand better what you have to fix. So it's only packages. So it will do the same thing. I mean, the image is already there. We have everything I need, just very brief stuff, but just this is the vulnerable packages we have in the image right now. So just to pick the one you want to fix, or, I mean, whatever you want. So yeah, so this part is okay. And what we can do also is we have the, I mean, we have the recommendation button in desktop, and we also have the exact same thing on the CLI. So instead of running this CVS command, I can recommendations, and I will just add one flag, that's the tag. It's exactly something at the drop-down where we select the tag 314. So if I just pick 314 here, I will have exactly the same thing. So it will just display the different. So yeah, so with the font size is just some wrap of the text, but it's the same thing. We have the image. We know that this base image is 314, and we can also see that we can also find the image on the different tags, because I mean that's the way we did all the tags. Most of the time of the images are tagged multiple times, and we have the different recommendations with all the details. So you can see like all the vulnerabilities that have been fixed and why we should pick this one. So this one, for instance, I mean it's the more recent one. It's pushed recently. It's also the latest tag, so it's probably one of the more up to date we have. Like we don't have new vulnerabilities. Sometimes when you update, you just add more vulnerabilities, and it removes some, etc. So you have all these details. You also have the size and I mean all that stuff. So you can pick the one you want, and then I mean you just rebuild your image or pull a new base image. I mean whatever the way you build your image. So we try to have the same thing on the CLI and on desktop. So you just have to pick the tool you prefer, depending on what you like. Yeah. So did you manage to get the images? Yeah. Are you able to explore a bit like the commands, the CVS command, the filters and stuff like that? Just to know if we just spend a bit more time on that. So obviously, if I run also the CVS command against the other image, so it's the V2 with just the new from command, we can see here there's just only these two high vulnerabilities. So yeah, so basically it's exactly something as desktop. One thing we have on the CLI that we don't have right now on desktop, and that's quite interesting, is we can also compare the images. So the thing is, we have the image, the V1 with the Alpine 314, and we build a new one. But what can be interesting is to see what are the differences. Compare. So we have this one, and we just add the two. So we just not mess up with the name. DC3. Continue. Service. V2. Yes. Yeah. So yeah, we have the policy also, but we will discuss more the policies after. So we just focus on the rest. If that just works. Yeah. Okay. So what we can see here is the difference, the comparison between the two images. So on the left side, we have the first image we use. Yeah, I think it's because I messed the two. But yeah, let me just redo that with the right number. So what we want is to see the V2 and just to compare with the V1. So yeah, it will be in the right order this time. Okay. Yes. Okay, so what we can see, I mean, we have the two images with the digest and the tag, etc., and we can see that everything we fixed there. We can also see that we added some packages. I mean, and the image is a bit bigger, even if we just change the base image, but it has an impact even in the packages we have, not just the version, but there's more packages. And so the main thing is we fix all the vulnerabilities from the base image. And then we can just see all the differences. So we have all the packages, like we added 7 packages, we removed 3, and I mean, a lot has changed. And so we have all the list of all the packages with the 2 versions. And then we can see like, I don't know, like this one, yeah. This one has been removed. This version, this vulnerability disappeared. And we have that for all the vulnerabilities. So this one is not removed, but we just changed the version from OpenSSL 1 to 3, and a bunch of vulnerabilities just disappear at the same time, etc. So that's pretty cool, because what we start to have is to know what are the differences. What is the impact of a change? I mean, sometimes we just update from image, a base image, but just, I don't know, because there's a new one. But what really is the impact? Maybe, I don't know, maybe we needed a very specific version of one of the dependencies, and something will break after. So it's good to be able to compare, better understand what is the impact of what we're doing. So this part right now is not in desktop, but yeah, we can have that on the CLI for now. So that's the compare. Yeah. And then the last bit, because if we go back to, let's say for desktop, we still have some issue there. We still have some vulnerabilities. So the idea is we can explore that, and we can see that. So the vulnerabilities are coming from this layer. So it's where we added the npm packages, and one of them has an issue. So it's the express one. This one is just a dependency of the express one. And so we can explore the details of the vulnerability. And then I think it's this one. We can know like the affected range. So this one is pretty simple, but sometimes it's way more complex than that. And we can also see the fixed version. So what is good is we have this information, so we just have to update the, let's just update that, the package. So it's front-end package JSON. And somewhere we have here the dependency. So if I just change with the fixed version from desktop, and I just update the tag just to have a new one, and rebuild. Okay. So it should be faster because it's just the last bit with the Node.js part, the npm. Yeah. Okay. A few seconds still. Okay.
This is the first one that's critical. In order to see, like in the page,
Okay.
it showed how to
Okay.
vulnerability page.
And if I go back to desktop, for instance, I would just go to the to my image. So I think it's this one. Yes. It's just analyzing. I mean, analyzing is just we index the image like we're creating the SBOM. We just list all the packages of the image, and then we compare that to databases of vulnerabilities. We don't really scan the image. I mean, it's not scanner. It's different. We just index. But now I have my image that is full green. I don't have any vulnerabilities anymore. So yeah, just by following the instruction from desktop or from the CLI, because we can do the same thing, we have all the details, all the information to fix that.
The online saying the audio is very low.
And then, I mean, if you have time, I mean, you can also like run again the compare command just to see everything that has been fixed.
For the online attendees.
And I can also show you there's one other command that I pretty like. So it's the V1. No, it's the V3. There's also one command that is
So it's all
quick
it's a single
view.
for the recording.
So this one is, yeah, is sometimes pretty, I mean, convenient. It's just, there's way less stuff display. It's just, okay, give me the quick view. Give me just an overview of my image. I just want to know if there are vulnerabilities, are they coming from the base image, and basically that's it. Or maybe the recommendation. So if I run that again against the first one, it will just give me some recommendation to update the base image. So it's the kind of stuff we can just plug right after a Docker build, for instance. Like we can Docker build an image and Docker quick view, and boom, I just have my really high-level overview. I don't have the details, but I know if I need to go deeper or if everything's okay, and I can just continue my work. So yeah, I think that was the main commands. I mean, then the idea is for you to explore, I mean, the different commands, the different filters. I don't know if you need more time, I mean, just to explore that, or if that's working. If you have time to test? Yes? No?
So we'll give everybody a few minutes to sort of play around with that. You can use the other image, work through the vulnerabilities there. Got about 7 minutes left in this section.
So everything seems to be working through
Or if you have any question, I mean, we're getting the
desktop.
commands or
When I try to
options
run
or
the
whatever.
commands from here, like none of them work. I don't know what I'm doing wrong, but all of them say I can't.
Full failed. Status failed to get image.
Like across the board, all of them.
Yeah, it's somehow not.
So yeah, I'm just adding new filters. So this one, I mean, I just added the only package type. Just try to find my cursor. Yeah. So it just gives us just the Node.js one. I mean, the npm one. So like, if you're a JavaScript developer, maybe you even don't have the permission like to update the base image because someone else said it. So you can filter down the list of CV just for one specific type. Or if you're looking for specific vulnerabilities, you can also put a filter, say, okay, I want to know if there's this, I don't know, log4shell or whatever SSL important vulnerability, so you can filter that. What what is
Did
there?
you build? Did you
We can
build the
also like
I did, yeah.
I think it's severity. Severity, like
images.
critical.
Oh,
because
you
that's
built in with DC23.
like I want to ignore all the like the low level. I mean that's sometimes the one we don't really care because they are not exploitable. So I mean sometimes the list of vulnerability can be huge. So there's a lot of small filter in there to find the right one we want. So like yeah, we want no critical, so we can just filter that and see if it's good or not, and we just ignore the rest. So yeah, so here it's just yeah. C'est libre que nécessaire, yeah.
That should fix it.
Right on.
Okay. Can people hear me still? Yes? Through them? So, okay. Apparently there is no mute on this thing. All right. Yeah, we got about 4 more minutes in this segment, so we'll just let people, like I said, catch up. If you're done with the exercises that we've done so far, feel free to interrogate the other image. The other image has dash back at the end. It's Scout Demo Service back. So that's going to have some vulnerabilities. So the image we've been playing around with is on the front end. That uses Express, NPM. The back end image is a Go image. So something a little bit different. It'll have some vulnerabilities in it as well. You can investigate the errors in there, the remediation recommendations. You can use Docker Desktop. You can use the CLI. Just go through that. And if anybody is having any trouble, has any questions, seeing any issues, now would be a good time to raise your hand to receive some assistance. We're friendly people. We're not mean. Here we go.
Sorry about that.
No worries. That's why I'm here. It's amazing that tape doesn't work, huh? What do you?
So I'm at the bit where we want to. Here, you want me to make this a little bigger for you?
Yeah. I mean, my eyes are terrible.
But
anyway.
so I'm at the bit where I want to update the front end dependencies. So I can see that basically the issue is QS and Express. So I can see Express. Hopefully that'll help you a little bit.
Right.
I can see Express here, but how am I supposed to see where the QS
It's the QS dependency that you see in your vulnerabilities for the NPM is actually brought in as a dependency of Express. So updating Express is going to update QS as well. So you really, it's a transitive dependency. It still shows because it's installed in that layer, but fixing the version of, updating the version of Express to, I think the 0.3 version is where the fix is. The 0.3 patch level, updating to that will also update the QS transitive dependency, and so it'll get rid of both of those.
How much delay we have? The delay we have. Oh yeah, because this one. What?
All right, we have another minute or two to play around, catch up, wrap up. And we'll move on to section 2. Everybody's favorite topic, supply chains. I'm going to be talking a lot about the Toyota production system. No TBS fans here? No? How can I help?
I've been having issues updating. So once I updated, it just kicked me out. So I put install and restart. So you recommend deleting that? Oops. Apparently I can't even open it. It gives me this error.
Yeah, I would go to the website.
Download
Just
it.
install it, yeah, and overwrite it. Just don't use the in-app thing. Just download it.
Don't use the what?
Just don't use the in-app upgrade. Just do it from the website. And like I said, while that's downloading, you should be all these. The first.
I was able to play with it.
Yeah.
It was just
The first.
giving me a hard time.
The first 3 sections you should be able to do with
Okay.
the version you have on the CLI at least. Okay, we're going to kick off supply chain discussion. But before we do that, I just want to acknowledge that this is where the workshop ends if we're talking about a security tool, a security scanning tool. We're talking about the other security scanning tools that are focused solely on dependencies and your code and your Docker images, your container images. We're done. This workshop is an hour, not 4 hours. Okay? But again, as I mentioned earlier, Scout is not a vulnerability scanning tool. It is a supply chain tool. Now, what does that mean? This is the segment where we're going to talk about what it means to be a supply chain tool. So buckle up. This is a lot of content. We're going to go through a lot of things here, but may run over the 15 minutes, but we'll make it up later. Okay, so what is the supply chain? How does this come into our conversation? There's an organization that was founded by through an executive order here in the US called the Cybersecurity and Infrastructure Security Agency, or CISA. And they have an open source security software security roadmap that they published just last month, actually. And in it, they define 2 aspects to the threat model of your software. Okay? The first, we've talked about, the cascading effect of vulnerabilities in widely used open source software. Okay? But they define a second vector of attack, and these are called supply chain attacks on open source repositories. So one way that you can get attacked is through vulnerabilities, some bug in some code somewhere that presents an opportunity for someone trying to infiltrate your system. The other way is that someone can poison the source of the software itself. So it's not a mistake someone made, but it's an intentional act that someone does, putting poison into the water supply, if you will, sort of somehow infiltrating HTTP site, FTP site, package site, somewhere where software is distributed, taking the thing that's supposed to be there and replacing it with something that gives them a vector into your attack, or into your system, right? And so here's also published last month in TLDR Security, an overview of software supply chain security. And in it, they talk about 3 different ways that your supply chain can be attacked, or rather 3 ways that you need to think about securing your supply chain. There's the source. This is your dependencies and your code. There's the build process itself. And then how it is that you package and deploy your software. And so what does that look like in terms of your software development lifecycle? Well, let's use an analogy. This is an analogy that we've used before in the Scout team, and it's how to make a cup of coffee, right? To make a cup of coffee, you need water, you need coffee beans, and you need a coffee maker, and then you need some way to get that coffee into your mouth. You need a cup. Okay? But what is this check mark here, right? That tells you that these coffee beans were grown sustainably using fair labor practices, right? So there's more than just going to the grocery store and buying coffee beans, right? Those coffee beans have to be grown, they have to be harvested, they have to be roasted, they have to be packaged, they have to be transported, and that to the grocery store so that you can get your coffee beans. Similarly for the water, right? It just doesn't magically come out of the tap. The water is obtained from a source. It's filtered, it's cleaned, it's purified. They put some fluorine in there so your teeth don't rot, and you get your water, right? So there's a supply chain that you have to think about, but each of the sources of your materials also have a supply chain, right? Just like the coffee, just like the water. And so when we think about source, we think about build, we think about package and deploy. How do we map them onto this analogy? Well, you have your sources, your coffee beans and your water. You have your build system, your coffee maker, right? And then you have your packaging, the cup, the mug, okay? And so you as a consumer or a producer of these things are kind of at either end of this thing. And so how do we map that into what we do as software developers, right? Well, it's a very similar sort of thing. You have your code. You're the producer in this scenario. You have your code, your source code. You have your dependencies. That's other people's code. You have your build system, your CI/CD, the instructions for how to build things, and the machinery upon which it's built. And then you package it into a container oftentimes, or maybe you're producing upstream libraries and you're packaging them in jar files or what have you, but you have your package, and then you have the people that consume that. So maybe you're deploying that code onto a Kubernetes cluster, maybe you're deploying your Maven packages onto Artifactory or what have you. And if we think about what we talked about in the first section of this talk, it covers scanning your vulnerabilities, or scanning your package, scanning your dependencies, and maybe scanning your source as well, right? So there's a lot of other points in this supply chain, this software supply chain, that are not covered by vulnerability scans and code scanning. You know, and these are some of the questions that if you're interested in truly securing how you build software, that you have to answer. There are a lot of places where things can go wrong. There are a lot of questions that you need to answer, right? Who is the producer of this software? Are the dependencies actually the ones you think they are? Has something happened to the source code between its production and its use downstream? Was it somehow manipulated with? Has the build system been tampered with to inject artifacts, code, what have you, into the system, into the software as it's being built, right? Once you build it, is it altered before it's packaged? Once it's packaged, how do you know if that package has been compromised? And how do you know if the package that you're downloading is up to date? There's a lot of different parts to this flow, a lot of different parts to the system that you have to think about, well beyond just scanning for dependencies. So the bottom line is that remediating CVEs is not enough to secure your software. Right? This is maybe what security folks tell you. This may be what the SOC 2 analysts tell you, but it's not enough. We have, as I mentioned before, scanning for CVEs only targets 2 or 3 of these questions. And so how do we begin to think about answering all of them? And so first we need to establish a common language. And so there is this industry working group called SALSA, the Supply Chain Levels for Software Artifacts. Sounds delicious, I know. Get some salsa on that breakfast burrito, right? But salsa is basically focused on the build, how you're building things, what's going into the build, how it's built, and what's coming out of the build. And it's about the integrity of each of those pieces and transparently communicating that so that other people that are consuming the output of your build can trust what you've done. Okay? And it provides different levels of compliance. All right? So again, it's focused on what's coming into the build, how it's built, and then how it's packaged so that the consumer can trust what you've done. All right? And it provides these levels of compliance. So first level is level 0, which congratulations, you are all Salsa build level 0 compliant, because you don't have to do anything for that. So you're already on track to be doing the right thing. You can give yourself a pat on the back if you wish. Build level 1 is about how it's built. And that's called provenance, showing how a package is built. Build level 2 is focused on making sure that there's no tampering after the build. Build level 3 is about the actual build process itself and making sure there's no tampering at that point. And so what does that look like for developers? Well, in Salsa build level 1, it means that you have to document what you've done. Now, this documentation doesn't have to be anything extra. A GitHub action workflow specification serves as a document of your build process within the Salsa framework. There are plugins for Jenkins that will produce a Salsa level 1 build provenance document for you. So you don't actually have to do anything other than leverage these technologies. That's good. That's good. Build level 2 builds on build level 1. You need to have that documentation. But you also then need to run on a hosted platform that generates and signs that provenance. So build level 1 is about generating that, documenting that build, that is creating the provenance file, provenance document. Build level 2 is about using a platform that generates and signs the provenance. And we'll get into more detail about what that means later. And it's also, we talked about that transparency bit. It also is about publishing that provenance, that signed provenance, to allow downstream users to verify it. Build level 3 builds on level 2, which builds on level 1, and then adds that element of the build system itself. You have to ensure that the build runs cannot influence each other. What does this mean? This means your builds are going to be slower because you cannot cache between builds. You don't want something poisoning that cache and then ending up in your artifact later because someone was able to influence that build through another build. Okay? And then you also have to produce the signed provenance that can be verified as authentic. So not only can they verify that it happened on your system, but they can verify that your system is who it says it is. And we'll talk more about what that looks like later. So just to be clear, build level 3 is the goal. And what has been implied, one thing to note is that where you do your builds can set the upper limit for how compliant you can be with these Salsa levels. All right? GitHub Actions is Salsa build level 3 compliant. Google Cloud Build is Salsa build level 3 compliant. There are other systems that are not. So without using a system that's already been certified as build level 3 compliant, you would be limited to a build level 2 compliance. But build level 3 is the target for your systems. And so what does that look like? You know, where does Salsa map onto this? It maps all around it, right? It's trying to put controls around all these things. How you get your sources, how you get your dependencies, how those feed into the build, making sure that those things are verified, making sure that your build is repeatable and untamperable, and that same thing for your package, that your package cannot be tampered with. So how do we start? How do we begin? Well, we're developers, and we believe that we should be using easy-to-use tools. This is from an article last year on RedMonk. Developer experience is security. Security, and the bottom line of this article is that security at the expense of usability comes at the expense of security. That is, if you make it hard to do, developers, are not going to do it. So we need sophisticated tooling that makes all of this easy to do. And that's where Docker Scout comes in. I've mentioned a few times now that it's not a CVE scanning tool. It's a software supply chain tool. And how does it do that? Well, it basically wraps around the whole system, right? If we look back at where Salsa wraps around the whole system, this diagram of Scout looks very similar, okay? It's building on trusted content. It's verifying things, like our Docker official images, Docker verified publisher, Docker sponsored open source. It's ensuring that when you're downloading dependencies, that those get verified, okay? It's about establishing a system of record, tying in not just as one element of your build system, but ingesting information from this whole pipeline, from this whole supply chain, and being able to reason about it. We saw before, it doesn't just think about a point in time. You're actually able to compare two different images, right? It understands about those two different images and how things change from one image to the other. So it can understand whether you're making things better or making things worse. And so it provides this system of record. And then at the end of this, in the section 4 of this, we'll talk about policy evaluation and how Scout goes about that as well. All right. Got through all that with only 2 minutes over. And what we're going to do now is have a 15-minute break. So we'll get back here about 9:30, 9:32 Pacific time. And then we'll go into another hands-on portion where we're going to talk about how Scout becomes this system of record, how it ties in to your software supply chain easily and to help you out. So take a break. There should be, the bathrooms are off to the left over there. Should be stuff to drink and stuff like that out there as well. And if anybody's still struggling to sort of catch up or, with their system, Docker desktop installations, what have you, feel free to reach out to us and we'll help you out. All right? See you in 15 minutes. So in this hands-on portion for section 2, we're going to connect Docker Scout to your data model for developing software, and so establishing Scout as a system of record. If you want, you can reset your GitHub repository to the hands-on 2 tag with the git reset hard command there. Yves?
Okay, yeah, so let's just first do that, the reset, git reset, hands-on 2. Okay, and where is my... Okay, I'll just, okay, I will just make it a bit bigger if I can. Yeah, okay. And just the instruction. So the idea first is, yeah, to just pick the right hands-on 2 tags, just to have the right readme. So the main idea is to, start to connect the images. Right now, I mean, we saw to get the vulnerabilities, see how to remediate them, but locally with the CLI or with the Docker desktop. But what's interesting now, I mean, is the second part is so we can connect and start to create this system of records so we can track everything. So the first thing we'll do is to see how we can integrate registry to the website part of Docker's code. So it's code.docker.com. We can do that with Docker Hub, but you don't need Docker Hub. I mean, it can work with any registry. We already have integration with like the AWS is here, but we can also integrate with, even a local registry can work also. So we'll just do that first. So the idea is, so we'll see how it will work with the network, but the idea is to go to Hub and create some repository. So we'll push the image, and we will connect this repository with Scout. So the image that we push will be visible directly on the website. So everything we saw locally, we can show that on the website, and some differences also. So the first step is that. Maybe it will take some time, to push the image. So maybe you should start with that. So just go to Hub on your account. The one you enroll for Scott, create the repository, and then there's two things. So you can go to the website scott.docker.com, log in, see the integration, and enable this repository to Scott. And then, so we can do that using the website, or you can also do that using the CLI. So just pick the one you prefer. And then we'll just push the command. So we'll just push only one for now, but it's just Docker push with the name of the image you already did. And we'll be able to see the image. So it just, I will do that just after, but you will be able to see on the website directly the different images and all the details you saw on desktop here. So the thing is, once it's integrated, it means like if it's your CI that pushes an image, you will see that. So you don't have, like desktop on your CI, but you can still see that directly on the website. So let's just do that. I will go to. I just open. Capture Docker Hub. And let me just click my stuff there. Where is that? Okay, so can I do that? Yeah, okay. No, I think it's, okay, it's not the right organization. Let me just pick the right one. So, all right. Okay, so I will make that a bit bigger. Okay, so it's just my an empty organization. I can just create one. So it's good. If I'm talking right, it's good. Gmail service. I just create it. So it's good. And so if I go to scott.docker.com, yeah. If I type it right, it will be better. Right, and yeah. So it just said that I don't have any image. It's just an empty repository, an empty organization. Let me just make it bigger. Yeah, and I can go there. See my repositories. Yeah, and the one I will just enable this one, activate image analysis. So, okay, once it's done, every image I will push will be available on the website. It will also be available on Hub directly, so I can see the vulnerabilities directly on Hub, or I can see them on this website. It's just a bit different, but we can see on both sides. Here, on Docker Hub, it will just be the layer view we saw on desktop. Here we have way more features in that. So I will just, so I think I just have the wrong organization, so I will just do that, Docker Scott configuration, no, configure, organization, so it's this one. No, what? Yeah, it's config if I don't type the right one. Okay, and I will just retag the previous image.
Isn't it WS3?
No, I will just retag that. Yeah. So it was DC23 with 3. That was the previous image. I mean, it's just not the right one. Scott Gmo service v1, and I will just retag that. Yes, Scott Gmo service 1. Okay, and I can just push it. Docker push. All right, so yeah, okay, so that should be okay. And now if you go back to Scott, so it can, I mean, sometimes it can take just a bit of time to ingest the image. So we just refresh that. So by ingest, I mean, we will just create the SBOM, so all the material of the image, like all the packages and stuff like that, and this is what we will show there. So it's like when we open the image on desktop, we can see that the start indexing, this is what the server will do. So let's just refresh. Not yet.
They don't need to do the extra tagging though, right?
No, yeah, the tagging is just me that used the wrong organization at the beginning. You don't have to tag your image first. It was just for me. Okay, all right. Maybe I can just show on hub. So I have my image. Okay, so it's not yet there. Okay. Sorry, so we're just waiting for the image to be there. And if not, I have a second organization I can use for that if that doesn't work. Okay, yeah. Okay, I will just pick the other one just to start to have something. So let me just pick this one. As you saw, I make a lot of tests with that. So yeah, so here. Oh, okay, it's not the right one. That's, okay, let me pick the right one. Why? It's not working. Right. If I pick this one. Okay. Okay, if it's not working, I will just pick another one. I just have a backup there. So it's this one. Okay, and I can see the images. Maybe I can just close that. Okay. Okay, so, I mean, it just, you should see, I mean, this image if the push is working. So basically, it's the same startup as in desktop. So we can see like the image. So the policy, it's something we'll show later. The image layers. So this part is, I mean, it's basically what you have on desktop or what you have on the CLI, but it's just there. So that is, you just connect your CI system, and you will see all the images there. Where is my? I'll just pick the next part. Yeah. So you can do the same thing as before, but it's just images. What can be interesting then is we can add another type of knowledge there, of record is we can record any image to an environment. So the idea is like, you build your image, that's one thing. That's, you just saw all the images, but it's not because you have an image that this image like is in staging or in production or whatever. And if you have vulnerabilities on an image like built by a pull request, it's not the same thing as if you have a vulnerability in an image running right now in production. So we can record that. So it's in the, where is that? I'm just trying to find the right window. Yeah. So the idea is, we're adding the image to the, so the push, we can add the, and see everything, as before. The push, yeah. And so we can do that. So I will just check one last time if my image appears, so I can continue with that, and if not, we will just continue with the previous one. Images. Nope. OK. So we have one command that is DockerCon environment. So let's imagine we merge a command. We merge the pull request with a new image, and we'll say, OK, this one will be staging. And on the deployment, we will say, OK, this one will be deployed to production. So then we can start to, we don't have to remember exactly the tag of the digest of the image. We can directly access to the details of this image, of the last one running in production, in staging, and compare, and all that stuff. So if, the command, the command is just this one, so it's just DockerCon environment. The name of your environment, you can put any name you want. It's, if you have staging, production is one thing. If you want, I don't know, a special environment for, I don't know, a group of applications, you can also do that. You can do whatever you want. It's just up to you and like the way you define your application and your production system. And you just put the name of the image, with the tag or the digest, if you want to use the digest, whatever. And if I pick my image, let's go back. I think it's images. That's working. Oh, and I don't have my environment there. OK, fine. Very good. Where is my image? All right. So I just picked another one. But that's the same thing. It's that's changed. I think it's just the size. OK. No. OK. The headers. The menu just changed, so I don't know exactly why. But yeah. So yeah, I have my staging environment. So then I can just filter this view and only see what's running in staging. So I have only one, but obviously you can have any repository you want. And it will always display the most recent one for an environment for a repository. Like you don't want to see like the tens of images you run for a repository, older version. What you want to know is what's running right now in my staging environment. So that's why you connect that directly to your CD pipeline to record that. So whatever the thing you, even if you push new images because you're building pull requests, you're merging stuff, if you don't record it, you still have this information there. And I just that. And so what is interesting, so which one is this? The thing is you can now compare. So I see if that can work. Because it's not the right organization. So it was one. All right. I just retag my image just to have it working. It's one. And I just want let's say the 3. OK. So what you can do now, we saw the DockerCon compare before. So DockerCon compare, DC23, there is 1. And it was good. demo service v3. And what we can do now is just, I want to compare to the environment staging. And it should work. No. Why? Why it's not working? Mm-hmm. Why? Workshop 1, schedule service. Okay, let me just check why my image is not there. Okay. Okay, I'm not sure why it's not working. I just try to fix that quickly. If I just do that.
What? I got. No, we haven't done that yet. That's the next section. We're on section 2.
That's annoying. I just have nothing working. And the free website just changed. And they changed the menu of the website. There's nothing, I mean, just during the presentation. It's, I don't know, I pushed my mouse like 13 minutes ago, and they still don't appear on the website. So I can't.
Did you push it to WS3 or WS?
I checked again everything, but the image has been pushed. The repository is enabled, and it's just not working on something. Okay. So it should appear at some point. I can see it. Yes. Okay, so I think it just took way longer than expected. But my image, I mean, I can see the vulnerabilities, it's on hub. So if I go back to Scott, it means it has been ingested as expected. So it was just this one. And why? Okay, okay. So finally I got my image. So this is the image. I mean, it's just what we had in desktop with all the layers, etc. So what we'll do now is we will record that to an environment. So let me just pick the name of the image. Yeah, my window is there. So DockerCon environment. Let's call it DockerCon and my image. And it's because I changed the name of the organization. No, invalid image. Why?
Can you go back to, what is that? Is that there?
This one is the right one. The GBRS, the repository is Codoma service. This one.
Are you logged in? What is your environment? What is your organization?
I just said the same. DC20 suit release. It's just the same thing. So
Did you push that? And you pushed that image.
Yeah, it has been pushed. Did anyone already have the image push on hub and can see the vulnerabilities? Just to see if it's just me or not. You can't hear me? Okay. Have you succeeded to push the image to hub? Okay.
How many people have pushed the image to hub successfully? How many people have seen it in scout.docker.com? How many people have been able to run the environment command successfully? Fewer. How many have been unable to run the environment command successfully?
Okay.
Are you seeing this error? The 400? No? Something else?
Okay, but yeah. So if you already push the image and record to an environment, you should be able to compare with the --2 env. Is that working? Yeah, okay. Okay, so it's maybe my setup that is not good then, but at least it's working for some. That's good to know.
Too much switching orgs.
Yeah, maybe, maybe. How can I try that? I don't know. Let me just check the next step just to. Yeah. So if you have your image, you can also compare the images on, like if you push the next one, I mean the V3 or V2, I mean whatever the name, you can also compare them directly on the website.
Where are you getting?
Well, so I'm getting, there's
I can
nothing in the
probably just demo that because I already have, images.
So
So
I
I
did
think it
notice
was in another organization. So yeah, I have maybe too many organizations.
that command never happened in 3. I don't know if that's important or not.
Yes, and
Yeah, that
if I go to my images,
Hey,
if I pick the right one,
Eve,
yeah.
you have to do registry : / when you do the environment.
Maybe I just. Not the Docker. Yeah, okay. So I just mess up with my own command. That's great. So yeah, I just forgot that. I mean, the thing is, what you want to record is the image on the registry, not the image you build. And in that case, it's, I mean, I'm probably in a case a bit special on my laptop for that. So at least it works there. So
So
Go back up one.
if I go back again to the right organization,
so
Okay.
I had to retag it.
so it was this one here.
Pushed up.
And
And then
if I display the
Where's
images,
that?
images,
Is that the error here? No, that's the compare.
all right.
I do the
And if I list them, but the environment didn't appear. Okay,
so
close. Why?
yeah, okay. So I ran this one.
Mm-hmm.
And then I pushed V3.
Why it's not refreshed?
Mm-hmm.
Okay,
And
let's
I tried
just
to do
pick
the
one other.
environment, and there's nothing.
I don't know why it's not working. Images.
And then environment staging tells me there's nothing.
Series.
Then I
Okay.
compare.
So one of the things we have on the website is, and what we don't have on the Soprano is we can also compare. I mean, it will be basically the same.
So V3 is.
Perfect.
Which is weird because
Can you go to here?
Okay.
Okay.
It's
So
perfect.
maybe go back and try to push the V1, or try to set the environment to V1 again.
Why it's not working?
What was that?
this one.
Yeah.
Okay. So yeah, we can see. I mean, it's basically what we have on the CLI, but if you don't like CLI, it can be better, and it's also better. I mean, because we can
Now do this command.
more easily filter. So see the vulnerabilities, the differences, see the differences in terms of packages.
Oh, that's
Yeah, so just display, I mean, everything that has been removed, added,
processed over here.
the different versions,
It's hard to say.
yeah, all the vulnerabilities we fixed.
There you go.
Yeah, so that part exists. Just trying one last time to have this image working, the stream. Images, where my stream?
Does anyone else have any issues with any of these commands?
Okay, I don't know. It's maybe me. Okay. Sorry. So anyway, if you have your images, where is my? Yeah. If you have the images, right? Yeah. So you should be able to run this kind of command from your CLI. Just if I can just hide this button, no? How can I? Okay, so it's staging. So the nice thing with that is, I mean, often when you deploy an image, when you build an image, you will tag it with, I don't know, like the Git char or any version or stuff like that. So
Can you try to?
if you want to compare, you need to know which one is in your environment. With just the compare to env, I mean, you just don't care. If someone else push something, you can see that, you can compare. Because at the end, that's what you want. I mean, what you want is to make your image better than the previous one. You don't want to make it worse. I mean, so you're doing a pull request and you just want, I mean, in your pull request say, okay, my image fixes this commit or doesn't introduce a new one. a new vulnerability, or I don't know, doesn't increase the size. I mean, it's not just vulnerabilities, it's maybe a package you don't want, it's maybe you increase the size of the image so it will be slower to pull and to run, etc. So that's the thing you want to have directly. And it's something that doesn't exist, I mean, by default. I mean, if you just push your image on a registry, you don't have that. You don't have this knowledge. The idea of Scott is to start to record everything. So you have your image. You can start to record where it's coming from, like with this is coming from this Git repository, but it's also running right now here. And so we can see here like the, to record that with your CLI. You can also do that, I mean, obviously with the, on the CI, on your CD pipeline, I mean, with the GitHub action or just calling the CLI also is working. And we will also have some integration like with Sysdig. So like you have like an agent running, let's say, inside your Kubernetes cluster. And this agent will automatically record everything that is running. So you even don't have to care about that. You just have your agent working somewhere, and we start to record everything. So you don't have to manage that by hand. But all the data will come at the exact same place in this, I mean, in all the data of Scott. And so you can start to query stuff from one side to another one. But I still don't know why it's not working on my version. Nope. Okay, so yeah, as it's not working, I will probably not be able to show more on this side. I think, yeah, I mean, it was just the comparison. And yeah, I mean, the next step of the, I mean, this hands-on was more to, like, you want to record a new version, and you want to see, I mean, what are the differences, what you improved, basically, on these images.
All right, great. If you are having some problems, raise your hand and Eve will come around and help you. I know over here we're having a problem over there. There does seem to be some delays in ingesting all these images on this in the back-end system right now.
No, this is
we have our best people working on it. But
you use the,
we will
kind
of move on a bit to
I thought it was your username, right?
yeah.
the next segment, if I can find it. There we go. All right. Yes.
Environment staging. Okay. It's
Sure.
I mean, say that you don't have permission, so you need to be an owner of the organization. But if it's your own username, you should be.
Yes. So the question was scout.docker.com. Scout is specific to Docker. If your registry is elsewhere, can you still use Scout? Can you still use the CLI? The answer is yes.
Yeah.
So right now we have integrations for Hub, Docker Hub, ECR,
Just to verify.
and Artifactory, I believe. And then Azure Container Registry is coming soon. So if you're using any of those, we can integrate with those. I think maybe GCR as well. We'll get into all the integrations a little bit later, but not only can you use the CLI, but you can also still use scout.docker.com. We're not ingesting, we don't have access to the images at that point. We're just the metadata about the images we're ingesting. So, all right, moving on to attestations. So how does this magic work exactly? So you'll remember this diagram before about our software supply chain. Your code, other people's code, the build systems, the package, right? So as producers, if we're on this end, if we're the people writing the code, bringing in the dependencies, doing the build, and packaging the software, how do we communicate the information about what we're doing as we're gathering the source code, building it, and packaging it to the consumers of our packages? If we're creating Docker images, container images that other people are using, how do we communicate the information about what's in those container images to others. And so there's a few ways that we go about doing this. There are some standards in the industry. First of all, what is in the artifact? What is in this Docker image, this container image? We use what's called a software bill of materials, or SBOM. And it's what's called an attestation, an assertion essentially about what's in the image. And it's essentially a list of the software artifacts that went into this package. And we'll talk in more detail about what that looks like later. When we talk about, so the SBOM kind of covers the source and the dependencies. So it's kind of going back to our making coffee analogy, it's the list of materials, the ingredients that are in your container image. How we describe the build is what's called our provenance. It's a different type of attestation about how something was created, right? So this is your recipe about how you're making your coffee. Right? So it contains information about, where it was built, how it was built, what was the environment, what was the operating system, these sorts of things. And then the other piece, when we talked about the supply chain, was verifying that these attestations, these SBOMs and the provenance are correct, that they have not been tampered with, they have not been modified.
I don't have that.
And we do that through signing these artifacts. Okay? Creating cryptographic signatures on these artifacts, actually on the checksums of these artifacts. And we'll get into more detail about that later. So what does the SBOM look like? How does one make it? What does it do? Right? And so again, remember, the SBOM is the ingredients list for your container image. Okay? So what system is going to know about the ingredients? Well, when you build it is when you have the most relevant, current, accurate information about what is going into that container image. So it's actually during the build, using build kit, which is the default builder now when you do a Docker build, and you add a command line argument. It's actually, you can use one or the other. These two commands are equivalent. You can do docker build x build, which is now the same as docker build. You supply your tag, and then you can either say attest type equal SBOM generator equal the scout SBOM indexer, or you can use the shorthand version and save 10 characters of typing by doing dash dash SBOM equal generator equal docker scout SBOM indexer, right? And so at the build time is essentially when you are providing and creating that SBOM, that software bill of materials. So if you think back to when I asked you this question, what if I told you you could stop scanning your software while improving your security? This is what I was talking about. Okay? Yeah. If you add an SBOM attestation to your Docker image using the command previously, Scout will use that SBOM as the source of truth for what is contained in your Docker image. And so when Scout goes to index an image to figure out what's in it, if it finds an SBOM, if you create one for it, it will leverage that SBOM. If it doesn't find one associated with that image, it will scan the image itself and make one and store that. So this is how you can improve your software security by adding an SBOM in at build time when you actually know what's going into that Docker image, that container image, rather than doing it after the fact. So no scanning, and you're improving your software stance. So just a couple more notes about SBOMs and Docker images. By default, when you provide that command line argument dash dash SBOM, it only creates an SBOM for the terminal image in the Docker file. So if you have a multi-stage build, like this one here, where you're doing a from Alpine, doing some work, and then from scratch and copying in from the previous stage of your build, if you do --sbom, by default, it's only going to contain the SBOM information from that terminal image in your Docker file. If you want it to also include SBOMs for the intermediate images, the earlier stages, you have to set this build argument, build kit SBOM scan stage equal to true. And because it is a build argument, you can override it on the command line if you wanted. You could disable it by on the command line doing --arg build SBOM scan stage equal false, for example. And if you have more than 2 stages, you have to put this in for every stage that you want an SBOM generated. Or you can move it to the top before the first from, and then it'll apply to all the stages. Or you can put it at the top, and it can instead of saying true, you can give it a comma-separated list of the stages for which you want it to create an SBOM. And there's documentation on this, but that's basically how you get it for more complicated build scenarios, multi-stage. Okay? Another thing is, and this kind of gets back to my point about creating these SBOMs when you have the information on what's going on. These SBOM scanners are only capable of detecting certain types of software. Okay? They understand distributions. They understand if the base image is Alpine and it finds an Alpine package archive, it can read that to figure out what packages are installed. It can read an apt archive, so if you're using Debian or Ubuntu base image, it'll understand what packages have been installed. When it scans the image, it can also detect, oh, this is a Node or a Python image. I know how to get version information out of that image, and I can put that into the SBOM that I generate. But it only goes so far. Sometimes you have to help the scanner out. If you're installing your own software, something that you've built, you have to help it out and say, I installed this. And you basically do that by putting a JSON file in the layer where you install that software. Okay? And you can use the copy and the here docs index to do this. And these are the elements of that JSON that you would need to include to have the SBOM scanner pick that up and include, in this case, RabbitMQ, a RabbitMQ version, into the SBOM that it produces for that image. All right, so again, and clearly the benefit here is that you're doing this when you're doing the build. You know what you're building, so you can provide this information and be more accurate. Because if you don't do this, and you're manually building RabbitMQ, for example, and you're just using a scanner, any sort of scanner, whether it be Scout or Gripe or whatever, or Trivy, they're not going to detect that RabbitMQ's there, so you're going to want to put that in there so that you make sure that your SBOM is accurate. All right, and there's also tooling to help you view SBOMs. We'll run these examples in the hands-on, but the build kit has an image tool inspect that allows you to extract that out, as well as Scout has a couple different ways to do it that make it a bit more readable and usable. So SBOM is your ingredients. Provenance is your recipe. How do we do that? Again, at build time, it's going to be at build time when you know how that thing is built. So build kit is doing the build, so it makes sense that it should be able to produce the information to provide the provenance. And so again, we have 2 equivalent commands to generate it, one using the attest option, one using the shorthand directly for provenance. Both take an argument mode, where that can be min or max. We'll talk about that on the next slide. And then you can view them, again, using image tools under the build kit. Oh, I should note, you notice this salsa here, right? So we're generating this provenance under the salsa property. So the min and the max for provenance, what do these do? For the minimum, you're getting build timestamps, the front end used like a Docker file, the materials, source code repository, build platform, and the reproducibility of it. Things like the environment variables, the OS version, that sort of stuff. The version of build kit that you use to build it, right? The max option has everything in min plus like a low-level build definition, which is the sort of internal representation within build kit that maps a specific front end into a generic format that can then be used to write one of its several different front ends. And as well as some other information about the Docker file, the full Docker file, as well as the relationship between the layers and the build steps. So the max level ideally should be used whenever you can. But because it contains essentially everything that BuildKit knows about the build, it's going to include things like the values of build arguments and that sort of stuff. So if you are passing sensitive information in using build arguments and stuff like that, you should not use the max attestation level because those will leak into the provenance. Okay? But you really should be using build secrets and stuff like that so that they don't, so that sort of information doesn't end up on your command line for one, or certainly not in your provenance. So there are ways around that. And the documentation around BuildKit and how to generate provenance contains information about all that stuff. Finally, we have our attestations now. We have our list of ingredients, the SBOM. We have our recipe, the provenance. How do we make sure that people can trust those things, that they can verify those things? And we do that, like I mentioned before, with cryptographic signing. Signing establishes two things: integrity of the artifact and the identity of the artifact, who created that artifact, right? So you essentially create a checksum on the artifact, and then you cryptographically sign that. The checksum verifies the integrity, and then the identity, or the signature, is done with a private key that is connected to a public key that is then connected to some identity, right? And oftentimes, this is used, like with a, signed by a certificate authority, signing keys, or those sorts of things. And so, at this point, you think about, well, what does that mean? Like, how do I connect that identity to an actual thing? How do I trust that that identity is who you say you are? And so if you think about, like, now, who do you trust? Right? You download software. At the beginning of this, or in preparation for this workshop, you downloaded something from Docker and installed it. So you trusted us, Docker, to do that for you, right? And you have a lot of, most people have mobile phones these days. You trust, the Android ecosystem or the iOS ecosystem to install software securely on your mobile device. Operating systems. You install packages on those, either from the operating system vendors themselves or from third parties like Homebrew and Chocolatey, right? Or maybe you trust GitHub, or you trust these foundations, CNCF and Apache, right? Like, but how do you establish trust? How do you begin to establish that trust? Well, there's actually a generic framework called the Update Framework, or TUF, that goes about trying to generically provide the infrastructure and the rules and the tooling to establish trust of any entity. So it's not just someone you know and trust, but you can establish it independent of that. And so you can think of TUF as essentially like a generic way of establishing, like a browser certificate authority store, or an app store for your mobile ecosystem, or a package manager for your operating system, right? Those establish trust in some way, right? Your browser, you downloaded it, it has to root certificates for certificate authorities in there, and then whenever you go to an HTTPS site, it validates that the certificate used on that site can be connected through a chain to one of those root authorities that it trusts, right? Similarly, app stores and package managers, they have public keys shipped with them, and they want to make sure that anything that they're downloading is connected to, is associated with, was done by a private key that's associated with one of the public keys that they know about, So what these things are doing, these CA stores, these app stores, these package managers, and Tough, it's establishing secure distribution of software artifacts, by establishing trust, verifying content, also allowing for evolution, right? Your package managers tell you when new software is available. Your browser tells when new versions of it is available, and those new versions may have new root certificates, right? And also communicating these updates. And so Tough creates the machinery to both, kind of establish, rotate, and revoke trust, providing essentially lifecycle management for trust. Okay, and that's all I'm really going to say about Tough and signing today, other than to say that, if you're interested in these kind of things, there will be a talk on Thursday called Building the Software Supply Chain on Docker Official Images. James over here, along with Ethan Heilman, is going to be giving that talk. It's Thursday at 11:45, and it's going to go a deep dive into signing, the current state of the art, and what we are going to be announcing at that talk is what we kind of think of as the next big thing. Okay, there's also going to be some mention of this tomorrow at the day one keynote, but diving into the details of cryptographic signing and advancement of the state of the art on that is going to be on this Building the Software Supply Chain on Docker Official Images on Thursday. All right? So time for our next hands-on. We're going to kind of do some builds, create some provenance, create some SBOMs, and view those. So you can reset your repository back forward, I guess, to the hands-on 3, and we'll do the hands-on. Eve, over to you.
Okay, so I hope it will be better this time. With that, I just check my own just to be sure this time. DockerCon config. Okay, so this one is okay. Just to be sure. Okay, so I will just pick the instruction at the same time. So where my tag and this one, okay. Okay, so if you remember, we saw the recommendation. Yeah, it was this one. So and we put this tag here, this 314. So I just removed that. So it will just use the base image, the way it has been built. And if we do that, we'll have some real results where I can just say, like, hey, yeah, you should change your image to 316. Or maybe you just have an image 3, and maybe you have to refresh that. But if we look at the Docker file, so the Docker file, what we put here is the from Alpine 314, and even a very specific version of this one. But by default, the image we build doesn't have this information. The only information we have, in fact, is the digest of the image. But this digest has been tagged under the 314, the 3, the 314.1, the latest. So we don't know which one to pick because it's an information that doesn't exist by default in an image. And that's why the thing we want to do is to add this provenance stuff. This provenance will include this information saying, okay, at the time of the build, you use this base image, it was this tag with this digest exactly. So now we can create all this recommendation and everything we want based on this information that just disappears when we build an image. So this is what we'll do. We'll just rebuild the image, and we'll add this provenance. The only thing we need to care about is on your local machine, the provenance will not be stored because it's stored as the same way as the multi-platform images. So what we'll do is we will add the attestation and we'll push the image and we will use that from the registry. So I will just just edit very quickly the Docker file. It just, I mean, oh yeah, I already have it. I mean, it's just one line. I mean, it's just to force a rebuild, because if not, everything else is already cached. I just want a full build, I mean, with the different digests, etc., just to have a new image. And so we will just Docker build. I will just add my tag. So it's, if I'm right, Scott demo service. And I will just add a tag that is okay, nonce, okay. And what I will do is just what we send aside, so provenance, okay. Okay, and mod max. And we'll push it directly to the registry. So, okay, what are you wrong? I'm not in the right directory. This time should be good. So, I mean, the image itself is built the same way as before. That's not a big issue. And where is that? Just, okay, yeah, here it's written. I mean, we're exporting an attestation manifest. So we're adding more stuff, I mean, inside the image. So we'll have the image and we'll have the provenance at the same time. And so if I rerun the recommendation, I just here, and I will just say, okay, just use my image from the registry, and it's called provenance. This time, I should have the right recommendation by default. So, yeah, what I can see here is, where's my base image this time is 314. The previous time it was just 3 because that's only what I know. I mean, that's one of the options. In that case, I know exactly which one of the image has been used at the build time, and so I can select directly the right recommendation. That's why provenance is so important for that, because without that, there's always cases where we don't know exactly how it has been built, so we can't really pick the right recommendation for you. So you have to select it. So if you select it, it means you have to know exactly, but that's not what you want. I mean, you want this result by default all the time. So, and what we can do is also just very briefly look at the provenance. So with BuildX, we have some tools. One is called image tools. It will be able to inspect the images, and so we can export, I mean, and display the provenance. So it's, yeah, I mean, we will not go into the detail of the file. I mean, it's just a giant, I mean, yeah, quite, I mean, that small, I mean, file with, I don't know, like all the steps, for instance, all the steps, what are the different digests, what else we have? I mean, we have all the metadata around the build. I mean, that's the main point. So it's about the build and not about the image, I mean, the final artifact. It's really all the recipe around the build, all the commands, all the environment, all the version. I mean, what was the digest of this tag exactly at this time, etc. So we can replicate the build, we can do all the right recommendation. And the second thing is we can also add the SBOM. So what we are doing, you can see if you run some commands or if you saw that in desktop, we have this indexing stuff. So the indexing is we'll grab the image, we'll read from the image all the packages. But it's something like I need to do that, someone else in my team will need to do that. What you want is to publish that along with the image at the build time. We want to generate that at build time and not on everyone's machines. And we will package that inside the image. So it's the same thing on the hub, on scott.docker.com, on your machine. You just have one single SBOM that has been generated everywhere. So we'll just do that. So if I just read it, the file, I will just, change this the missing at the end. Okay, and my build. No, it's not this one. Docker build. Okay, and I will just add this. Just put that here. The SBOM. And one thing we will do, I mean, you can just add the SBOM. That's fine. But we also develop one specific indexer from the code. So it's using the exact same code that is running like on the website and on the CLI command. So we can specify the generator. So SBOM generator, Docker Scott SBOM indexer. Yes. And I mean, we did that because we added some layers. I mean, it's using Sift inside, but we're adding some more stuff to find some like we're able to find some issues with Go standard library that some other cannot find by default. So it's even better to use this one. So you have exactly the same result, whatever the way you look at the image after that. So we just add this SBOM and we push that. Oh yeah, and I will just change the this one. Let's go and attest. Yes, attest. Okay. So it will write that. Yeah. So here we have it resolved the indexer. So it will pull. I mean, it's a Docker image, and it will run against the artifact we just built before we push it, and then we're pushing everything, including the SBOM. So we now have an image that contains, the image itself, the container image, the provenance attestation, and the SBOM attestation all at once. And I just picked the, so yes, if we can see that if we just run, like even just a quick view, I will just forget this one just to say this is the image from my registry. And if I do that without the SBOM, we'll see that it will store the image. Store, it means it will pull the image, look at the content, create an SBOM locally, and cache it locally, because we don't want to do that every time. This time, we will see a bit different logs, just saying if, okay, yeah, just saying, okay, we have the provenance obtained from the attestation, and we have the SBOM obtained from the attestation. So the result I have on my side is exactly the same if you run the same command. If the image is public, you can, I think the image is public, so you can even run the same command on your side. You will see the same result because it's coming from the exact same SBOM that is stored inside the registry, inside the image. And then, if you really want, we can also explore the SBOM. It can be big. This one is not a very, very huge image, but like if your image run, I don't know, sometimes you have images with hundreds and hundreds of packages. So for each of them, you'll have a lot of details, like also containing all the locations of the file that say, okay, this is this package, etc. So it can be really huge. But we have some tools for that, because that can be useful. What? Yeah, it's not the... Okay, so we have this command. So it will just display, and we can, it will display the SBOM in SPDX format. So let's just see. Yeah, so we'll not go through all the command, but yeah, you have. I don't know if I can just pick something interesting in the packages. I just try to find a package. Yeah, okay, you have. Like this file name, you have also like some licenses somewhere. All packages have their own license. Yeah, there's way too much stuff in the SBOM, and the goal is not to read that by hand, it's just to have tools on top of that. But based on that, even without to discuss, even without to discuss about vulnerability, we can also do some stuff like I want to see all the packages of my application, of my software. Even if it's not the vulnerabilities, I don't care, I just want the list of my packages. that's something, most of the time you don't know. I mean, if you're building an image, you know probably the packages you're adding, but most of the time you don't know the dependencies of the dependencies you're adding, and you even don't know the one that has been added by your base image somewhere. And sometimes it's bad. I mean, you want to know what's inside your image. And so you can just, I mean, the SBOM, just say, OK, this is what you have. This is the version. This is the package. I mean, you have everything. And of course, I mean, it's a command we already saw before, but it's directly linked on that. So this one is only about the SBOM. And the other version is just about the CVs with the format-only packages. It will just say, OK, this is based on the same information, but with the vulnerability for each package, because that's the goal of our tool also. So yeah, I think that's quick overview of what we can do. So the best is to do that. I mean, if you, I think now by default, we have the provenance min that is enabled. So every time you're building, like on, I don't know, if you're using the GitHub action to build, you will have the provenance. It's the min because, as we said, sometime in the max, you can have stuff you don't want. So by default, we will just rely on the min. If you can just use the max, enable the SBOM. I mean, like for every build, I mean, it will not take that much time on top of the classical build, but it will be better. And once you have that, we can just enhance all the results because we will continue to build stuff on top of this provenance and SBOM. So yeah, so if you want, you can try. I don't know if you try to build and push and see how it's working, just to see, I mean, the different commands. And yeah, I mean, I think that's the main part, I mean, of the SBOM. I mean, it's, you have the same result everywhere, and especially the provenance, that is really, really important. Yeah. Did you succeed to have it working, to have some results? Yep. No? Oh, if you have a question regarding the provenance and SBOM and all that stuff. So one thing is, let me just, no, it's the provenance. Maybe not, I don't know.
If you go to the service levels of that.
Just wanted to show if we can have the
Go to the image layer.
It should pick the right one now.
Yeah. Well, we can just move on.
Yeah, okay.
Is that it? Is that it for the All right. That kind of wraps up the attestation portion of the segment, so the hands-on, and We're scheduled now for another 15-minute break. It's about quarter till 11 here in the Pacific time zone, so we'll reconvene at 11 a.m. Feel free to go out and get some refreshments, and we'll see you back in 15 minutes. Thank you. Hello. Welcome back. Hopefully you got refreshed a little bit during that break. So now we're in the home stretch, the last hour, last full segment. We're going to be talking about policy. What do we mean by policy? Well, in general, when we talk about policy, we're just talking about the rules of the road. If we think about where this workshop started, if anyone can remember that long ago, your security organization may impose some policy on you, right? To say you can't deploy anything with a critical CVE in it, right? That's one kind of policy. And maybe that's communicated in a meeting or a Google Doc or, on a wiki page, or just, from one team to another in Slack. But that's not how Scout approaches policy and compliance with those policies. Remember, Docker is focused on developers, creating tools for developers. And Scout is a developer tool. So Scout approaches policy the way a developer would approach policy. So what does that mean? What does that look like? So imagine, if you will, a scenario. You get an alert, PagerDuty, whatever, on Slack message, something's down, something's not working, high levels of 500s or whatever. You investigate, you isolate the problem, you write a test, you fix the bug, you run the test, it works, create a branch, commit those changes to a branch, push the fix up to your source code repository, create a pull request, you get the pull request reviewed, approved, and you merge it. The build for the merge goes in and fails because there's a CVE in there. Now, that CVE existed in the currently deployed version as well, but because you have some sort of policy or something that you can't ship software with vulnerabilities, the thing crashes, and then now you have to go fix something else, and the delay, the breakage, lasts a longer time. Your service is down for even longer. How many people have experienced something like this in their development? Yep, a few? I know I have. It's not fun. Because what do you end up doing? You just end up putting an exception somewhere so that it passes anyway, and you just keep going. Because if you change that dependency, who knows what else is going to break, right? So that's not the way Docker Scout works. Because as we've seen already, Docker Scout understands your supply chain. It understands what is running where. It understands, it can compare one image to the next, right? And so Docker Scout's approach is first, do no harm, right? And this quote is most famously associated with the Hippocratic Oath, but apparently Hippocrates never said that. And as far as we know, Morpheus didn't either. That's a callback to an earlier reference in the talk. I know it was a long time ago, but try to stick with me, all right? So first, do no harm. What do we mean by this? How many people are familiar with the term Kaizen? Anyone? Kaizen? Yep. All right. This approach is present in a lot of agile methodologies, right? And it's borrowed from the lean manufacturing sector, which in turn owes a lot to the Toyota production system called TPS. And it's basically a term that has come to mean continuous improvement. So if you're in agile methodologies, if you're doing retrospectives and these sorts of things regularly, you're trying to improve how you do things. And that's Scout's approach too. It's an approach of continuous improvement, okay? So because Scout understands what's going on across your entire software development lifecycle, across your entire software supply chain, and it's a system of record, it understands what is deployed at any time. And so when a new build comes in, it knows if you've made things better or worse or stayed the same. And so when it's evaluating what's going on, when it's evaluating your build for whether it should proceed or not, it's doing that in the context of your whole supply chain. And so it's not going to penalize you. It's not going to stop. It's not going to break the build because the image running in production right now has 3 CVEs and yours also has 3 CVEs because it knows about both of those things and it knows that you didn't make anything worse, so it's going to let that build proceed. So there's nothing to be afraid of here. Scout is a developer tool. It is designed for developers. It's designed to make your life easier, not more difficult, not to make you jump through hoops that don't actually improve things. So with that in mind, Scout comes with several out-of-the-box policies. The policy portion of Scout is currently in early access, so you can check them out, and we'll check those out in a few minutes in the hands-on section. All right? So the out-of-the-box policies that it comes up with is basically critical and high vulnerabilities with fixes. Fix them. Don't let them go into production. Any critical vulnerabilities, stop it, right? Keeping your base images up to date, that's in general a pretty good thing to do. And it understands, again, because it has an intimate understanding of container images, it knows what up to date means, right? You know, node 3 yesterday is not the same as node 3 today, necessarily, if that tag has been moved to a newer image, right? So I should say node 18, that's more up to date, but you understand what I mean. It understands what, you know, not just the label and the tag that you use to build your images, but what that mapped to underneath, and if what it maps to underneath has changed from one data to the next. So this is kind of what it looks like, and this gives you some idea of what Scout understands, because not only do you see kind of what your current status is across these 4 policies, but you can also see how it's changed over the last 7 days. Has it gotten better? Has it gotten worse? Has there been no change? And you can also track these vulnerabilities over the last longitudinally amount of time, okay? Because it understands at any point in time what your software stance looked like. So Scout knows the present and the past. If you're interested in knowing in the future, that's day 2 of DockerCon. So go to that keynote for the future. All right, here's some more. You can dig into the policy details on the web, get an understanding of, you know, for this policy, are you compliant? Are you not compliant? Why are you not compliant? Okay, you have 2 critical, 18 high. All right, this is that image that we just built. And you can drill into the CVEs, the specific versions that are non-compliant, similar to what you did earlier with images in the first hands-on section. And finally, you can look, so before, in the previous slide, we're looking for a given image, or for a given image, what's it stands for a specific policy. You can also look for a given image, what is its stance across all policies. Okay? It's not compliant with these 3, it is compliant with the last. And then coming very soon, it's probably going to be deployed or released sometime today or tomorrow. You can also get policy on your pull requests with our GitHub action. So within the context of your pull request on GitHub, you can see, right, here's the current version, here's the pull request version. For each of the policies, you know, we're out of compliance on the version that's currently released. We've improved the stance on two of those, right? Improved, and 1 we made worse. We apparently installed a lot of GPL v3 software in this version. So you can see right where you're working right where you're doing pull request reviews, what does this look like from a policy standpoint? You don't have to go bouncing around to a bunch of different tools. We give you the information right at your fingertips that you need. So I mentioned the GitHub action on that last slide. That's coming soon. And then once policy becomes generally available in Scout, we're also going to have parameterized policies. So if there's certain software licenses that you want and certain software licenses that you don't as part of your policy, you can encode them in the configuration of that license policy and yeah, customize it to your use. And then eventually we'll also be introducing a language so that you can define custom policies that are specific to your organization. So again, Scout's intention is to surface the information you need where you need it so that you can move your organization ever forward, incrementally forward, improving over time to a more secure software supply chain. All right? So with that, it's time to get into the hands-on for policy. And here's the git reset command to get you where you need to be for the 4th installment of the hands-on segment. And with that, I'll hand it over to Yves.
Yeah. So let's start with that. Reset for and let me just pick the that is the 3, yeah, 4, where is that, tags, 4, all right. Okay, so we'll just, rebuild one image first. So let's just do that. I think I'm not in the right directory. It's, oh. Okay, just one time it's better. Sorry, so we just rebuild, the image just with a different tag. And provenance says bomb and just push that. So, yeah. All right. So, no, it's not the right command. Okay, so we have a new command that is the Scott policy, and then it's just the image as before. And why? I just not found. In organization, why it's good? Why I don't have it working?
Do you need local?
I need local? Maybe. Let's. Why? I just build my image. Okay. I just pick that one again. Okay, let's go. Let's see. Okay, I just have, I don't know, something weird. Okay, so yeah, so it will just evaluate, all the different policies we have. So we have 4 by default against my local image. And so we have, we have the, what we saw, we have this kind of summary of the policies. So yeah, it failed in that case. And we also have all the details. So you can even understand exactly what's wrong for each of the policy, like all the packages that contains some vulnerability. So you have that. This stuff is more just a current version. And you'll see later that we can also improve that. So we can also see will it works? I mean, I'll try again the, let me just pick, oh yeah, I don't see, where is my cursor? I hope it will just work this time. Okay, and if I go to my image, the 4, should be better this time. Yeah. So yeah, I mean, we have the, I mean, it's roughly the same thing. I mean, it's just the command but that runs on the server. And if we, I mean, then you can just explore, I mean, all the different information you have. But if I'm right, yeah, no, okay, it's, I think it's the right one. Yeah. Yeah, so you have the view by image, so you can see inside all images. And if you have multiple images, I mean, you can also see, I mean, like, all the ones that are good or not. So let's pick, I don't know, I mean, this one. So yeah, we also saw that. I mean, I didn't make it that really better over the last days, but yeah. I have my repository, I have my images, I can see the details of this one. But if you have multiple images, all failing the same policy, I mean, you will find all of them here. I just have only one here, but yeah. I mean, yeah, I mean, you can just explore all the stuff. So if you plug that also, I mean, it's just by default now. So if you push your image from your, I mean, CI pipeline, whatever, I mean, you will see all the policies, and you will see, so the policies by repository. So this is really interesting when you're working on one particular image. But as you can also see all the policies at the level of your organization, it's really interesting to have an overview of, okay, what's the state right now of my organization, or maybe what's the state of this environment, because I also recorded that. So I just want to see this really full view, like what policies are not, I mean, what's the state of the policies in production, exactly. So what we can do to see the changes in, we will just fix, I mean, the base image of the same image as before. So it was the front end one, the file, and just, I mean, replace that. Yes, with the from Alpine 318, and we'll just rebuild the image. All right. So in that case, we will just load the image and we will not push it. So it will stay on my local machine. It's like, I mean, I'm just doing my work locally. I want to, like, maybe I'm preparing my code before to open the pull request. But what I want to know is, did I make it better or did I make it worse? So what we can do is we can compare the images. So will it work? Because last time, okay, this one is okay. So during the compare, I mean, I skipped this part, I mean, earlier in the hands-on, but we have this comparison of policies. And that's pretty interesting. I mean, all that stuff is great. I mean, you can see, you can really dig into the details, see that, okay, this package has been updated, it's better, okay. But what is really interesting is this part. I mean, what you probably only want if you're making your code, if you're making your changes before to push on your pull request, this is what you want. This is, yeah, you want green here or just nothing because you just have no change on the policy side, but that is good. I mean, I improved that part. So I can safely open the pull request and do my best for the rest. If we just take the story before, like we have an incident, we fix something, we push, but there's this vulnerability. But if I just make the image at the same level of policy, I mean, it's fine. If I make it worse, meaning that I'm introducing a new vulnerability, okay, this should be gated, this should be probably stopped. But if I just make it the same, that's what I have in production right now. Maybe I don't need to get this deployment to fix a production issue just because it's the same thing. So this is really interesting to better understand. And as a developer, that's what really interests me. And I can see all the details in the compare because I want to fix them, but most of the time what I want to know is just that. Is it better? Is it worse? Should I fix that, or is safe to go to the production because I'm just making it at the same level of policy compliance as before? Let me just check the next step. Why? I think I have something. Where is? Why? Oh, yeah. Yeah, just one thing, I mean, I was just, this one, I mean, we improve. We improve, but we still have vulnerabilities. So if we just go back to the policy that was here, and we still failed the policy. So there's a real difference between the policy of an image and the policies at the level of the comparison. I can make my pull request because I'm making better, but making better doesn't mean everything has been solved. So maybe what I still want is to fix these vulnerabilities here. Where is, yeah. So what I will do is I will fix again the Node.js vulnerability. So it's in the front-end package JSON. So it was just this Express version. Just here, I think it's 3, if I'm right. And I will just build it again. And now, if I recompare the two images, this is the 4.2, okay. So I should make it even better than the 4.1. Yeah, we can also compare with 4.1, that can be interesting. And then, yeah, so it's all the thing that has been fixed. And yeah, here, so I still have my improve, so that's good. But at the same time, my analyze version, I mean, it's all green. So this one probably should just go to production as before. So I can push that. So just, just docker push. And push. Yeah, just. A bit more? No? Yeah. Okay. Please.
Push harder. You picked the wrong layer to modify.
It's a so big image to push. Yeah, no.
It's like some people are working ahead. Wi-Fi is starting to struggle.
Yeah. Just the time it's finished to build, so I will just, or maybe just the overview first. Yeah, so I mean, at least right now, I mean, the image is still doing the push. I mean, we have, all the three there, I mean, it's, none of them comply, I mean. So we'll see, I mean, the changes when it will be pushed. Oh, no. I'm trying, but yeah. Yeah.
Unwatched pot also never boils.
No, maybe it's. Yeah. 3 megabytes again. Yeah, it's big. It's big. Please. Oh, close.
Less than a meg to go.
One more. One more.
Now, your Wi-Fi icon is empty.
No, I don't have Wi-Fi.
I'm just saying it says the signal is very
I have
low.
a camera there. So.
I don't know. Maybe
Yeah.
the point here.
The numbers are great, but still not finished.
Yeah, 2 layers, we could be taking bets.
Yeah. Come on.
Somebody reboot the router in here.
Okay.
Yeah.
Right.
Well, cell signal here is terrible too.
I don't know.
There's no cell signal in this room.
That's, yeah. Please finish.
It's real close now. Real close.
It's, yeah, it's the right number, but still not. I don't know.
Its work is complete to 4 significant digits.
Please. Yeah.
You just had to walk away. It's him. It's him.
Yeah, no good.
So I can build it with the version create.
Yeah.
I try to do the command.
Just downloading a few movies for later.
Yeah.
Who's ever downloading movies for later, please stop.
Okay. In the previous command, I mean, there's with the -- load where I said we
Right.
push the image locally. This command works if you're using containerd, so you can enable it in the settings of desktop, but it doesn't work with the default image store because it's the way we build the images to embed the attestations. It made like a multi-arch image, and multi-arch images are not supported by default with the new image store. So we're working to enable containerd that will just fix that stuff, and that's what I have on my machine. So if you have an error message saying that what's the name? Docker Exporter does not currently support exporting manifest lists. It's just because you need to enable the containerd stuff. So it's in the settings. I think it's out of the
yeah, it's in
experimental stuff.
settings, experimental. So if you go to the gear and go to advanced.
I think it's stable enough, but if there's a question, it's Georgia there is working on that, so you can help on that. I will just, now it's pushed.
New features.
Maybe I have it on the website.
Containerd.
So this was the current version, and where is my? No. Yeah. Okay. So if I refresh that, yeah, and now I mean all my policies are just back to 100%.
Can you bring up Docker Desktop so we can show them where that
Oh yeah,
containerd
yeah,
setting
sure.
is?
So desktop.
So if you got this error about manifests when you did the -- load, go to Features and Development, and then click the Use Containerd for pulling and storing images.
Yeah.
The great thing about this is that it switches it, but all the images that were in the old store, the default store, won't be visible anymore. So you will need to rebuild the image again.
Yes.
So following the steps in 4. But Containerd it's in development, but this is what you want to use on your Docker desktop. I highly recommend using Containerd. It's a more advanced, it's a better system for containers. We sort of are continuing to maintain the default Docker runtime engine, but Containerd is the the new stuff that we're working on with the community. So, and it's the default in like Kubernetes. That's what Kubernetes uses now. So that's the way to go.
And especially if you have Mac M1, M2, where you're on RMS64, and most of the time you have your compute that is on AMD64, so you have to build in the two different platforms. With the containerd, I mean, you can build them locally, you can store them, I mean, you can have them. With the default store, it doesn't work. I mean, it's like the attestation. I mean, once you start to play with the attestation, with the SBOM, with the provenance, you're better with the containerd stuff. I mean, I have it enabled all time. I don't think I have. I don't remember issues with that for a long time. And I mean, I don't know exactly, but it will go out of experimental at some point. So, yeah, that's definitely the next part of that.
So we'll add that to the setup instructions.
Yes. Yeah. I think it's better to have it. If really you have an issue, I mean, you can go back to the previous one, so the image you have will not disappear. But most of the time, I mean, it's just so good to have it in containerd. So yeah, so what we did here, I mean, we build the new image, we push it slowly, but we managed to push it, and everything is back to green. So I think we can show that. I mean, I think if we compare also the images, yeah, we have. Yeah, I was just too fast on the click. But yeah, here we see also that we improve two of them. Everything is green now. And so if we compare like I don't have the 4.1, but we can compare that. I mean, we can see some part here. And in the compare, let's see. Oh, no, okay, we don't have that right now. I mean, it's on the, why am I? Okay, I think I don't know why the menu changed all the time. Okay, but yeah, I mean, I don't have changes.
Well, because 7 days ago it was 0, and now
Yeah,
it's 0.
okay, I think it's, okay. But yeah, I mean, I can see at least that everything is okay here. I should be able to see that also in the overview. Okay, maybe because I just push everything today. So.
All today, yeah.
Yeah. But yeah, so at least we can see that. I mean, if you have like more images, I mean, more realistic example, I mean, you will see all the policy changes over time. So it's pretty great to have a very quick overview of what's wrong, what's bad. And more than that, I mean, you can also select that with the, yeah, I don't have an environment here because it wasn't working before, but you can see that by environment. So like the policies you have in staging are probably less important than the one you have in production, and you probably don't react the same way. I mean, it doesn't mean staging is not good, but what is really important, for instance, is like what you have in production, because that's really where you can have trouble. So it's good also to see the differences by environment and see the progress between the different environments. So yeah. I think
And so another thing to realize is that all these things are updated dynamically. So as new vulnerabilities are identified and stuff like that, all these things will be updated. And because Scout not only knows the last thing you push, but what you have deployed to each of your environments, it can update you dynamically about the state of your exposure across all your environments at any time.
Yeah, and that's also the idea of Scout that is not a scanning system. I mean, like, if there's a new vulnerability that happened, one policy might fail, but you haven't rescanned any image. I mean, it's just the policy that failed because of the new vulnerability that happens, and that we compare to the result of the SBOM. So it's really, really different in that way, and that's the goal, to put all to record all this information in one central place, so we can connect everything and refresh as things happen. I mean, new data happen, some result might change, and you can see that and react on top of that. Yeah. Did you manage to have the like the policy commands and see that on the website? Yep, nope. Issues, help? Okay, that's.
All right, was everybody able to work through that locally, yeah? And again, if you did have issues with the manifest, the error, then just switching to containerd
Yes.
and running these as the backend storage should resolve that, and you can run through this again.
Okay.
All right, a little bit ahead of schedule, which is fine. All right, so now we're just going to wrap up real quick. I know it's been a long morning, but we talked a little bit. There was a question earlier about what if I use a different container registry? So again, Scout's aim is to be the system of record for your software supply chain. So it has integrations with a lot of different pieces, elements, tools, platforms that you use in your development every day. So we have, 3 different, container registries, Artifactory, Docker Hub, and ECR. And then Azure Container Registry is coming soon. We integrate with various CI/CD systems as well as environment monitoring. And there'll be a talk coming up, I think Thursday. I'll mention it later, but on the sysdig integration. That sort of brings more information and more value to the whole Scout story on the supply chain. So what we see here, what we've been learning about, what we've been talking about, is how Docker now, with the addition of Scout, exists and lives and provides value to you across your entire software supply chain. Starting with trusted content, or Docker official images, Docker-sponsored open source, Docker-verified publisher images, right? Build kit, providing provenance and SBOM information when you're building. Scout giving recommendations about how to improve your stance as far as security, signing images, vulnerability identification, Docker Hub and other container registry integrations, as well as the policy stuff that we just finished talking about in early access. A lot more to come there over the coming months. All these things position Docker to sort of help you out everywhere that you need to, everywhere that you work, everywhere that you need something done, Docker can help you out. So just some pointers now to some of the talks we've been mentioning throughout this workshop. Tomorrow, 9 a.m. is the day 1 keynote. There'll be a lot of interesting announcements, a lot of stuff around Scout announced tomorrow at that opening keynote, so I highly encourage everyone to attend that. Shortly after that, Eve is going to be giving a talk on an in-depth deep dive onto container images. So more about layers and how Scout can help you to interact with those and understand those. Our colleague Christian is going to dive deeper into SBOMs and provenance and these sorts of things, all demystifying the metadata around the secure software supply chain. Eve, very busy this week, will be giving another talk about finding out more about what's in your container using Docker Scout. We're going to have, I mentioned earlier about sysdig. There's actually going to be 2 talks that focus on Scout and sysdig. One is given by Eric Carter on Thursday, and the other one is given by Christian and Alex later on Thursday that gives sort of information about sysdig and how Scout integrates with sysdig to improve your understanding of what's running and what vulnerabilities you actually have. Mentioned earlier, also James's talk with Ethan about building the software supply chain on Docker official images. That's talking about signing. How does signing work? Why is it important? What are the foundations of those things? And how are we advancing the state of the art there? Very exciting stuff. I highly recommend that talk. And then finally, when you're talking about the future and you're talking about secure software supply chain and you're talking about provenance and all these sorts of things, what's next, right? We've been talking about what you can do now. But this talk by Thomas and Jim on Docker and Nix, if you're familiar with Nix, it's basically, or if you're not familiar with Nix, I should say, it's basically a way to specify your entire system when you build things. And you sort of build it from scratch each time. And that way, it's exactly specified, fully specified, reproducible, repeatable. You know, you can kind of think about it as like Docker without Docker files, in a sense. Okay? So that's going to be an interesting talk, kind of wrapping up DockerCon late in the day on Thursday. All right? Questions, comments, complaints? I was joking about the complaints. Oh, okay. Go ahead. Sorry? To access Scout through APIs? Yes. There are. Yeah, there is. I mentioned the 3 interfaces. I omitted the APIs. But yeah, the CLI, scout.docker.com, and the desktop all essentially are leveraging Scout APIs on the back end. And so there are API channels to do that. I'm not sure what the state of our public access for those are. I mean, they're all publicly accessible, but I'm not sure like where the documentation is on that, to be honest. But it is all API driven, yeah.
Yeah, I mean,
is there what? No. So the free plan for Docker Scout is 3 repositories, and then beyond that, there's a charge for it. But once you have, yeah, I mean, you can enable Scout and use it for free on 3 repositories. Other questions? Comments? Going once? Going twice? Thank you all for your time and your patience. I hope this was useful to you. I would guess you'll be getting a survey. We would appreciate it if you fill that out. Our future employment at Docker depends on it. No, I'm kidding. Yeah, thank you very much for your time, and have a good rest of DockerCon, everybody.